Hello everyone and welcome back to the channel. In today's video, we are going to be taking a look at how you can build your business analysis agent using a custom code interpreter with generative AI in Python. But before we dive right into it, do not forget to subscribe to my channel for the latest of data analysis across different technologies. In my previous videos on my channel, you would have seen I have solved a lot of data analysis and business analysis problems using Microsoft Excel. We have also taken a look at different machine learning problems such as linear regression and logistic regression using Excel. If you have not taken a look at those videos, do take a look at that. But in today's videos, we're going to be covering how we can build your business analysis agent using generative AI, where the agent does your analysis for you. We're going to be taking a look at the application that we'll be building, the architecture, and then a step-by-step instruction as to how you can build this agent for yourself. So let's get right into it and take a look at the application first. Okay, so this is the application you would have built at the end of this video. So stay tuned till the end. So let me enter a prompt here. Okay, let me expand this. So this prompt says an individual earns a gross salary of some amount, and then some deductions he has to pay like taxes, medical expenses, and other dental care. And also he has annual expenses on his daily expenses or monthly expenses such as rent, food, and other things. So we want to build a budget calculator. This can also be used for any business to calculate the budget. And what is his net savings? So this problem typically I would have solved with Excel, but now let us see if the business analysis agent built using generative AI can solve this. And this is a very powerful concept because you can integrate this with your app. So I have clicked on run and you can see it is generating and executing the code. And now this will run in the background. And once it generates, we'll quickly see the response. And then we'll also take a look at the architecture as to how this works. Okay. So this is now actually generating the code for you. You can see this, it has generated the code for you. Okay. And we'll take a deeper look at this later on. And it's not only generated the code, it has also executed the code and given you the output. And the best part of this is that it then passes the output back to the LLM, which will give the user a user-friendly output. So based on the provided information, his net income is $26,700 and the total annual expenses is 26,000. And currently he's left with a saving of $700 per year. So this is the application you'll be building. Now let's take a look at the architecture. All right. This is the architecture for your application. So what happens here is we input the business problem as a prompt, and this text is passed on to the LLM. Now the LLM tries to understand the text, but it only generates the text and the probable code that will solve the problem based on our prompt. Okay, so it generates the text and the code, but now our duty is to extract the code because we want to actually execute the code. We cannot execute the text, so we extract and pass the code. We build something called as the abstract syntax tree, okay, which helps you safely execute the code. And then we pass the code and execute the code, and the result of the code is then passed back to the LLM for a user-friendly output, as we have seen. So again, in short, the prompt is passed to the LLM, it generates the text and code, we take out the code, we pass the code, run the code, return the result, and pass it back to the LLM for the user-friendly output. Now let's take a look at this in detail using a Jupyter notebook. Okay, so we'll look at every step, okay, slowly and systematically. So first, if you have not install these libraries, LangChain, using the pip install command, LangChain-OpenAI and Python-.env. Okay, and later on we'll also be using Streamlit to build a custom app. But first, let's take a look at each and every function that we need to assemble to build this kind of an application. So we import the libraries. This is for the abstract syntax tree, the AST, the RE is for the expression, IO is for the input output and the streams. And then we import the chat OpenAI class from the LangChain library and the load.env, okay, function. So let's run this. Okay, and now this is run. Now we'll use the load.env function to load the environment variables. What this is basically, in your .env file, you can store this base URL, open API key. These are all your secret keys that you will need to access the LLM. Okay, so you can store them once you have got them from your LLM provider, and store them in the .env file and use the load_env function to load them up. And then you can use os.getEnvironment and load the base URL, API key, and pass them to this chat OpenAI class. So the chat OpenAI class is used to instantiate the chat OpenAI object, which communicates with the LLM and chats with the LLM. I've used a base URL parameter, which is a very important parameter because typically all the chat OpenAI class hits the OpenAI LLMs, but if you want to use your custom LLMs which have been deployed on your local environment or local network or any other open source LLM, you can specify the base URL class and give your own model which has been deployed across these places. So I like to set that because I don't want to be restricted to one model. I want to explore different models for my application. So then I pass the Open API key, which you can get from your LLM provider. And in this case, I'm using the OpenAI.GPT.4 model. You can use different other models and check your performance. Okay. And I'm going to run this. I've set the temperature to 0 here because I want a very, very deterministic code. I don't want the code to be random. I want the same results every time because when you're generating code, accuracy is the key here. Now, extract code. This function, as I mentioned, as we saw in the architecture, the LLM returns a text output as to how the problem can be solved along with the code, and it may also return some elements which cannot be executed. So what you want to do is you want to use an expression and extract only the executable code that can be parsed and can be executed. So this function does that for you. It takes in the text generated by the LLM and it extracts the code from it. Now, this function is a very important function called execute code. The first line is we initialize an input output stream. Okay. And to that stream, we write certain things. So abstract syntax tree is a very safe way to pass your code. And what this does is this generates an abstract syntax tree for you, which helps you visualize the code that is being generated. And also if there are any full elements, you can visualize and delete them. This is a safe way to parse your code, especially when you're executing code dynamically. And once you have passed the code successfully using the abstract syntax tree, you pass it on to the compile function. Okay. The compile function does nothing, but it compiles the block of code for you, which can then be executed in runtime using the exec function. Okay. So that is how this works. So let's execute that, and the value is then passed on to the input output stream. So let's execute this. Okay. Now we come to our main function. This function is called the run prompt. So this is our main entry point function. The user enters the prompt, which is the business problem. It's passed to this run prompt function. Okay. We are also using a system message because we are telling the LLM generate Python code to solve the problem. Okay. And we are invoking the LLM. Okay. So this is the LLM which we created on top here. Now we are invoking this LLM, okay, and we are passing your system prompt along with the prompt which has been generated by the user. And whatever content is coming, we are getting the code response variable. Then we are then passing the code response variable to the extract code function which we saw on top. And once the code is extracted, we are then executing the code safely. Okay. Now the best part is whatever is the result from the code, we are then passing it to another prompt which is called the summary prompt. We are appending the original prompt and the result with the summary prompt so that the LLM can then summarize the content as a whole. So this entire prompt with the original prompt and the result is passed back to the LLM as a summary prompt for the summary. So let's run this. Okay, this part is nothing but just for some formatting because we are going to be seeing the results in the notebook itself. Now I've created the same prompt which we saw in the example. Okay, I've given the same prompt, and this prompt now I'm going to execute using the run prompt. So let's click on this. It will take some time because it is going to pass it to the LLM. It's going to get the result from the LLM. It's going to extract the code, pass the code, execute the code, and pass the result back to the LLM. So it's quite a lot of many trips, but for getting a clear, insightful data for your business problem. So you see how wonderfully this agent works. It has executed in 17 seconds. Now this function returns three parts: is a summary, which is the user a friendly summary. It returns the output, which is the output of the code, and also returns the code. So let's see one by one. First, I'll print the code. So you can see this is the code that has been generated by the LLM. It's clearly broken down the problem into different variables as gross salary, the deductions. It has written how it's calculating the total deductions, what are the net income, and what are the annual expenses. Okay. You can click on scrollable element and see the entire, and it is showing you how it is calculating the total income and the net income. Okay. So let's print the output now to see the result. So the output has clearly shown you, as you have seen, $26,700 is the net income. Total expenses is 26,000, and the net saving is 700. But still, to present it to your end business user in a user-friendly manner, you want the total summary. So you can see that here it explains the problem. An individual with an annual gross salary of $50,000 has various deductions and resulting in a net income of $26,700. And with his total expenses, his savings is $700 per year. So the user can get a clear summary of the problem statement and not just see some numbers. Now let's take a look at this in Excel to verify. Solve this problem in Excel. I would have added I've taken his income and all the deductions, including taxes, medical, and got his net income here. You can see this. The formula text is here. Then I would have minus his expenses. So I've first totaled all his expenses. You can see here total expenses. And then his net savings I would have got from minusing the expenses from the net income, which is 700. And we can compare the values here: $26,700, 26,000, and $700 as the net savings. Same result we have got back in our LLM. Okay. Now let's take a look at our application and see another business problem, how it can be solved. Okay. Okay, now this is your application as we saw in the starting. Now this is another business problem. Obviously these problems are very simple, but I just want to show you the concept. You can expand your prompt and this concept to build a very complex agent, as you can imagine, and also multi-agents to solve multiple complex business problems together. So you can see here now I'm asking for a principal of $10,000 and the rate of interest of 5% for a period of years of 6. What is the compound interest? Again, I just click on the run here. And now you can see again it is generating the code here, the same process as we did earlier. Okay. And the same process, but now it has generated the code dynamically. So again, you can see you can give any problem, it can break it down into code dynamically. It will execute the code, it will pass it successfully and then execute and then give a user-friendly summary to the user. Okay. Okay, to build this application, as you can see, I've just copy pasted all the code we have seen in a notebook file here and I pasted it into a Python file. And this is a small Streamlit application I've written. If you want to understand how I built this application, do let me know. I'll make a video on that. But it's a very, very simple lines of code. You can copy this and you can try out the application yourself. Or better yet, you can embed this code in your own custom business application and make your own business analysis agents using generative AI. I hope you enjoyed this video. If you did, leave a comment on any such videos you would like to see from me and I'll make them. It gives me encouragement to make such videos. Do leave a like and subscribe to my channel. Thank you.